I'm Mike Zevin, an astronomer at the Adler Planetarium, and I am a project co-lead of Gravity Spy. So my research focus is gravitational waves, which are tiny ripples in the fabric of space-time that we started discovering in 2015. And these come from signals out in space like colliding black holes and neutron stars in the distant universe. Now, the effect that they have is to cause distances to stretch and squeeze. So I work with a collaboration called LIGO that has two instruments in the US that are built to detect these tiny stretches and squeezes of space. The problem is the typical detectors, which are about 2.5 miles long, the amount that they stretch and squeeze from these events is about 1/1000th the width of a proton. So it's very, very, very difficult to detect these things, and we need to make sure to understand and characterize all of the noise that are in our detectors. That's what the Gravity Spy project is about. We have way more sources of noise in our detectors than actual astrophysical signals, from gusts of wind, earthquakes on the other side of the Earth, a car running into the tunnel, which has happened, and even birds pecking. So the goal of the project is to classify and characterize all these different types of noise so we can get a better understanding of them, mitigate them, and possibly even remove them from the detectors themselves. Well, one of the most surprising results, to me at least, was when we were creating this project, we weren't really sure if people were going to be interested. We were very upfront that the goal of this project wasn't to find signals from space, but really to look at all these different kinds of noise that are affecting the detectors. And we were amazed by how enthusiastic the volunteer base within Zooniverse was at doing this particular project. And I kind of like to think of it as like cloud watching. All these different noise sources come in different shapes, and it's fun to kind of just cycle through them and see what you see. So the volunteers in this project look at things called spectrograms, which are essentially plots of the noise that is happening at a particular time in the detector. So they're kind of shaped and colored based on how strong the noise is and the frequency content, like the pitches of the noise if you were thinking of it like sound. And another thing with this project too is it was one of the initial ones within the Zooniverse to build in machine learning into the framework of how this classification is doing. And actually, the machine learning models and the volunteers kind of work in a symbiotic relationship where the machine learning model will decide which images would be best for the people to see, and the classifications by the volunteers in the project help to improve the fidelity of the machine learning model. Yeah, so this project actually found multiple new types of glitches. One that was found early on was named by the volunteers as paired doves because they looked like little birds sitting on an electrical wire or something like that. The problem with this particular glitch is that it wasn't found by the other software within LIGO, and it looked very similar to the signals that we get from merging black holes in the universe. So this particular glitch that was discovered by volunteers was really important because it kind of masqueraded as these astrophysical signals and made it more difficult to actually find the true signals within the data. So this was a hugely important find and was really exciting that Gravity Spy from the get-go was able to kind of find these new types of noise and get them out of the detectors. So even with all the improvements around machine learning and AI models, there's still something about human intuition that is unmatched. So I think that the Zooniverse platform is really a perfect place to be tying together both machine learning models and volunteer classifications in a way that maximizes the potential of both. So having Zooniverse volunteers is a must for this kind of science.